Alright, so for this problem, we are going to find the inverse of this function. So just like before, remember when you're doing inverses, you switch your x and your y, and then you solve for y. Now the one thing you have to realize is that y is in the exponent, and we also have a base of e, which means that to the inverse, we're going to end up doing the natural log. So the first thing we have to do is get rid of the 1/3, so we're going to multiply both sides by 3. And then to actually get rid of the e and to write this in the logarithmic form is we're going to take the ln of the other side and we're going to set it equal to the exponent. So then the last thing we have to do is divide by 2. And then of course remember our notation. And there's the inverse. We're going to do the same thing here. You should go ahead and give this one a try, pause the video, and then give this one a try so you can find the inverse. When you're ready, press play. So hopefully you start out by switching x and y. You wrote it to get rid of the e, and you set it equal to the exponent. You added 1, and then you divided by 2. And hopefully you got this as your inverse. Now it said to find the domain. Now one thing you should realize is that the domain of the inverse is really the range of the original function. Okay? And so if you look at this one, the domain of this function, really all it did was just move to the right one and was horizontally stretched by a factor of 1/2, but that didn't change the domain, nor did it change the range. So the domain was still negative infinity to infinity for this exponential, and its range was 0 to infinity, because again, the only thing that's actually going to change the exponential is the range, but only if it moves up or down, and if it's gotten flipped over the y-axis. But since it just moved to the right and was horizontally stretched, that's going to be your domain and range. So then the domain of our inverse is really the range of our original function. Go ahead and pause the video and give this one a try. When you're ready, press play. And then remember to get rid of the ln. It's going to be e raised to what it equals 3y. Okay? So then the last thing you have to do is just divide by 3. And that is your inverse. So by doing a few of these examples, finding the inverse of exponential functions and logarithmic functions makes a little bit more sense. Now here we have your laws of logarithms. Your laws of logarithms allow you to make evaluating laws a lot easier, as well as solving when we get to them in a few days. The first one is called your product law, which says that log of x plus log of y equals log of x times y. Log of x minus log y equals the log of x over y. And then there's a number in front of your log, so n log x, it would equal log x to the n. Okay? And then of course when you have 1 over x, you can rewrite it so that you have a negative in the exponent, and then of course you can bring that to the front in regards to this one called your power law. Alright? These are very good to know. These are in your reference booklet because you may be asked to condense a logarithm. So that is all on this side, okay? If it ever asks you to condense, it's the right side of the equal sign. If it ever asks you to expand, then it's going to be the ones on the left side of the equal sign. This one right here is just on kind of separate little law, but it's pretty straightforward. So we're going to use these to express some of these as a single logarithm. Okay? We're going to apply those properties, and we're basically going to condense this whole thing. Now, in order to use either your product or your quotient law, there cannot be a number in front of your logs. So anytime there is a number in front of a log, like in this case right here, this 1/2, you need to apply the power property and move it to the exponent. So then that's going to be log of 2, log base 2 of 5, plus log base 2 of 36 to the 1/2, minus log base 2 of 10. And now that there's not a number in front of any of your logs, then you can apply your product and your quotient property. Whenever there's a plus, that means you multiply these two numbers, okay, x and y. So we'll have a log base 2 of 5 times 36 to the 1/2 minus log base 2 of 10. All right? Now 36 to the 1/2, that's the same thing as saying the square root of 36, which is nothing but 6. So 5 times 6 is 30. So we basically have a log base 2 of 30 minus log base 2 of 10. And since we have a minus, there's nothing in front of our logs. Minus means divide, so we're going to have log base 2 of 30 divided by 10, which is nothing but log base 2 of 3. And that is our log, this original log that's in the red, written as a single logarithm. I want you guys to give this one a try. Pause the video when you're ready to check your answer. Same directions. Condense it as a single logarithm. When you're ready to see the answer, press play.
Charles Wilson to the front office, please. Charles Wilson to the front office.
And there's your final answer there. Remember, addition means multiplication, subtraction means division. Okay? Now, this problem right here is very common for an IB worded type of question. They're going to give you a log that has a lot of different variables and things in it, and then they want you to express it in terms of other variables. Like this case, it says, given that A equals log base 5 of x, B equals log base 5 of y, and C equals log base 5 of z, you have to write that expression in terms of A, B, and C. Now, in order to do this, you're going to basically need to get it to where you just have a log base 5 of x, log base 5 of y, and log base 5 of z, so that way you can plug in A, B, and C in for those things. So we're basically going to have to expand this log right here using our laws of logarithms. So we're going to start by getting rid of this division. Whenever we have a division, that means we're going to subtract the log. Now, what you'll notice is that y to the second, z to the second is actually being held together with a multiplication. And so whenever you have multiplication, that actually means addition. So it's going to be log 5 of y to the second plus log 5 z to the third. And the reason why I put this in parentheses is because I'm subtracting that entire log. So that means that both of those things had to be in the denominator if I was going to condense it. Now the last thing to do is realize that x can be written as 1/2. I need to bring my exponents to the front, applying the power property. And by doing that, what you'll notice is that I have just log base 5 of x, log base 5 of y, and log base 5 of z. So that way I can substitute in A for that one, B, and then C. And that will be your final answer. If you wanted to distribute over the negative, that will also be acceptable, but either one is the correct answer. And that's how you can use the laws to also, rewrite it using different terms. Now, your change of base formula allows you to use your calculator to take the log of any number, okay? With the base of any number, okay? So the log base b of a equals log base c of a over log base c of b. Now, normally c would be 10. That's what allows you to use your calculator to find the log of a log with a different base to a number. But also realize that when in solving some problems or simplifying some problems, that actually could be any base to help us in simplifying or in solving. Okay? So if you have something like this, you apply your change of base formula. It's a log of your big number over the log of your small number. And in this case, our c is going to be a base of 10. So we're going to plug that into our calculator, rounding the 3 significant figures, and we'll get 1.53. I'm sorry, not 53, 58. That was my mistake. Okay? Here's another example where we're writing an expression in terms of A and B. If we notice, it's log base x of A equals log base x of 3 equals A, and log base x of 6 that equals B. And we're trying to find the log of base 3 of 6 in terms of A and B. We're going to have to use our change of base formula. Yes, over log of 3, but this time, remember, that C, that base when using the change of base formula could be anything you want, and in this particular case, I want it to be x, so then that way I can substitute in B for the top and A for the bottom, so that way I can write the log base 3 of 6 in terms of A and B. Alright? Now, you guys are going to practice a little bit to writing expressions in terms of x and y. The directions are going to stay the same. Log base A of 2 equals x and log base A of 6 equals y. That's going to stay the same, but these expressions right here are going to change, okay? So I want you to pause the video and press play when you're ready to see the answer for these ones, writing them in terms of x and y, okay? So give it a try and then pause the video when you're ready to see. Hopefully you guys got that. Use change your base formula. That way you can plug in y for the top and x for the bottom. Pause it. Press play when you're ready to see the answer. Hopefully this one was easy enough for you. It's just the opposite, using the change your base formula. Pause the video. This one was a little bit tricky because it had 36, but you still applied the change of base formula. That's what you see here in the very first step. And then realize that I need it to be log base A of 6. So I can rewrite 36 as 6 squared, apply my power properties to bring it to the front, because the only way that I can actually plug in y is if I just have log base A of 6, not log base A of 6 squared. So I have to move that exponent to the front, and that will give me a 2 log base A of 6 over log base A of 2, and I can replace in my terms that I need, and I have 2y over x. Okay, I'm going to give you another one like that in this one, okay? So go ahead and pause the video, give this one a try, and then press play when you're ready to see the answer. Okay, so since it was already to the base of A, I didn't have to use change the base formula because it already gave me the base that I needed. Okay, but 24 is not 2 or 6, but I could rewrite 24 as 6 times 4, but then I rewrote 4 as 2 squared. Okay, that gives me 24. And since I have a multiplication, I can apply my laws of logarithms and expand it by using a plus. And then, of course, using the power property to bring the exponent to the front, because the only way I can plug in x is if I just have a log base A of 2, and that's my answer there. Pause the video, give this one a try. this is the answer for this one. Okay? You can rewrite this. You have to use a change of base here because we do not have a base of A. So we use change of base so that we can have a base of A. And then 12 can be written as 6 times 2. The multiplication allows me to expand it by putting a plus, and then I'm able to substitute in my terms. Pause the video, give this one a whirl. Log base A of 3 over log base A of 2, I have to use change of base. And the only way I can really get 3 is if I take 6 and divide it by 2, allowing me to expand this by using my subtraction, my quotient property. So replacing division with subtraction. And then I'm able to plug in and say this is y minus x all over x. That's my answer there. Okay? So being able to write these in different terms, it takes some practice, okay? But that's why hopefully you pause the video, be able to try yourself before you actually press play to see the answer. And then of course you have it on your homework. This one we're going to write in the form of a plus b log 3 of x. And in order to do that, looks like we're going to have to expand it. Now a and b represent some numbers, so we have to actually get it there. So remember, division means subtraction, so we're going to subtract the top and the bottom from each other, okay? And remember that 27 and x squared are held together by a multiplication, so this can be written again as log base 3 of 27 plus log base 3 of x squared. Remember, log base 3 of 1, that's one of your properties that basically says that that equals 0. Log base 3 of 27, using your properties, we're writing that in exponential form, that's 3 to the x equals 27. So this log actually equals 3. And then we can apply our power rule and bring that exponent down to the front. And if we notice, we kind of already have this form, we just have to distribute the negative through. And now we have it in the form of a plus b log base 3 of x. The only thing is that a is a negative 3 and b is a negative 2, which is fine. Okay, a and b are integers. It doesn't say that, and that was my mistake. I should have put that up there. All right, and that's the last little bit of your logs, of your logarithms, dealing with your properties. Okay, so hopefully this rewatch the video if you need to, and go ahead and then make sure you get to your homework.